Yeah, you can't see you.
Yeah.
All you're going to do is finish the vector packet that I gave you yesterday. Okay, so what I want to do first is go over the notes and show you how to change from direction magnitude into component notation. Why do we change into component notation? Why do we do that? Go ahead, David.
Because it doesn't always start at the origin.
Well, they never start at the origin. Even if we change it in x, y notation, it doesn't. It really helps us to do something with multiple vectors. Go ahead, Christine. Yeah, it really helps us to add them. In order to add vectors, and we see them in direction magnitude, we don't really get an idea of how far over they go and how far up they go, so we got to change them into their x, y notation so we can add them. Okay, so I'll do it longhand and I'll give you some formulas. So if I was changing this, the first thing I would do is I would draw a triangle straight down to the horizontal line. You should always draw your triangle straight down to the horizontal axis. If you draw it to the vertical axis, you're going to mix up some of the formulas, which means you're going to have to do it all by hand. Okay, always draw it to the horizontal axis. Okay, so straight down. Okay, now if you take a look, notice my angle's not inside my triangle, but I can easily find it. Go ahead, Christine. Yeah, so this will actually be 35 degrees. The two things I need to be able to change it into XY notation is I need this and I need this. The over will be X, the up will be Y. One trig function will find one of those for me, the other trig function will find the other one for me. What do you think, Eli? Go ahead, David. Sine and cosine. Now, which finds me which? Devin.
Cosine finds you x and sine finds you y.
Yeah, cosine will find me x, sine will find me y. Now, you can write it out each time. You can do the cosine of 35 equals x over the hypotenuse, which is 120, which means x is 120 times the cosine of 35. And the sine of 35 is going to be y over 120. So y is 120 times the sine of 35. Notice all we end up doing is doing the hypotenuse times the cosine of the angle and the hypotenuse times the sine of the angle. That will happen every time. So instead of writing the ratio and then cross-multiplying it, most of the time I just remember that it's always the hypotenuse times the cosine of the angle and it's always the hypotenuse times the sine of the angle. Okay, someone give me what's x about? Go ahead, Devin.
98.
98 point what?
3.
3. Okay, and how about y? What's y about? Go ahead, Christine. 68.8. So my answer would be now. I'm going to stop for a second. Something's wrong with my answers. Take a look at my vector. According to this, my x and y coordinates are both positive. And your calculator is always going to tell you they're both positive. Yeah, Christine. X should be negative. So what I really need is negative 98.3 degrees and positive 68.8 degrees. Now, that's something you can do every time, or there's a little trick in your calculator that you can actually have your calculator give you the correct answer with the correct sign. It won't always give you a positive answer. And here's what you do. You count this as being 0 degrees. If I go this way, it's a positive angle. If I go this way, it's a negative angle. If you count the angle as being from 0 degrees and you put it in your calculator, not only will it give you the correct number, but it also gives you the correct sign. So instead of using 35 degrees or 55 degrees, I could use 145 degrees. If I use the cosine of 145 degrees and 120 times the sine of 145 degrees, not only will it give me the correct number, but it also give me the negative when it should be negative. So it will give the correct answer and sine. Okay, I heard I'm confused. What are we confused about?
No, I got it.
Okay. It really is your choice. If you're someone who says, look, I'll use the angle inside the triangle and I can figure out myself if it's positive or negative, go for it. Okay, just make sure you do double check. Make sure you look and say, well, x is negative, so my x has to be negative, y is positive, my y has to be positive. If you're someone who doesn't want to check, they just want their calculator to do it, what you can do is you can figure out what the angle is from 0 degrees, and it would be 90 plus 55, which is 145 degrees. And if you use 145 degrees, you'll get the correct number and the correct sign.
That was my
So it's your choice. You could also use the negative angle. The negative angle would be 180 plus 35. So it would be 215. If you did negative 215, you'd also get the right answer. Okay, questions on that? Okay, so here is the formula if you're someone who likes formulas. To go into component, this is also called xy. What you do is you do the hypotenuse times the cosine of the angle, and you do the hypotenuse times the sine of the angle.
Hey, that's easy.
Yep. And it's your choice on whether you do the angle from 0 degrees or you do the angle to the horizontal axis. You still have to do the angle to the horizontal axis. Okay. Or you can draw the triangle and do exactly what we did at the top and just figure it out. Okay, questions on that one? Okay, let's do it the other way.
Yay!
For this one, I want to change from XY notation back to direction magnitude. Direction magnitude is what we think about when we're doing real world examples. I don't normally talk about moving in a horizontal and vertical direction. Okay, I don't, hey, to go home, I go 2 miles that way and 3 miles that way. No, I normally say I go that way, 5 miles, and it makes sense. Okay, so I'm going to do the same thing except for work my way backwards. I, again, going to draw the triangle up to the horizontal axis. And I need to find this angle here. And, well, if I'm using north, south, east notation, I need that angle. But if I'm doing from 0 degrees, I need this angle. So what I might do is I might go through that angle to find it. Sometimes you'll be using north, south, east, west, in which case you can say that, hey, this is south of west. Sometimes you'll be using 360 degrees, in which case the positive x-axis is always 0 degrees, and then you're going from that all the way around. Okay, how can I find the angle? Go ahead, Christine.
Well, you know that the shorter leg is -50 and then the longer leg is -130.
Okay.
Use tangent inverse.
Yeah, I can use the inverse tangent to find the angle. Okay, so x is going to be the inverse tangent of the opposite over the adjacent. What's a negative divided by a negative? Positive. Now, the reason why I point that out is here's an issue with your calculator. Go ahead and do the inverse tangent of 130 over 50.
60.9.
Does it give you a positive answer or a negative answer? Okay, so x is about, what was it?
68.96.
60, oh, so 69 degrees.
We're immature.
Most of the time, if it doesn't specify, I round to the nearest tenth, unless it specifies it wants it more. Okay, so 69 degrees. Take a look. There is no way that my whole angle all the way around is 69 degrees. But
Is it
x is 69, and then I have to add 180 to it. Now, here's one issue with tangent. The inverse tangent of, we'll call it an angle, will only give you an angle in the first or fourth quadrant? Because there's always two angles that have the same tangent. But your calculator, when it works its way backwards, it only gives you one of those answers. It only gives you the angle that is in the first or the fourth quadrant. So here's what you have to do. If you look at your angle and it's in the second or the third quadrant, just add 180 to it, because the angles are in complete opposite directions from each other. They're 180 degrees apart. So if your angle, or your vector, if your vector is in the second or third quadrant, add 180 degrees. So my answer would actually be 69 plus 180, 249 degrees. Okay. Yeah.
But isn't the angle of x still 69?
Yes. So here's the thing. If you're working in north, south, east, west, suppose you're doing a problem that's just talking about north, south, and east and west. You can find the 69 degrees, and then you just say it is south of west. It will always be from the horizontal axis, and then you can see that it's obviously south of west. But suppose they want the angle from 0 degrees. 0 degrees is always the positive x-axis. If I go 69 degrees in the positive x-axis, I am actually going to find this vector up here. This is the one that is 69 degrees. Mine is on the complete other side of it. So what I do is I say, wait a second, my vector is completely 180 from that. If your vector is in the second or the third quadrant, it's going to find the one in the first and the fourth. You just add 180 to it. Okay? Now, if you're doing north, south, east, west, you don't have to do that because you can just figure it out and it's south of west.
If your
Yeah.
vector's in the second quadrant, don't you only add 90 because it's only...
No, here's the thing. If the vector is in the fourth quadrant, it'll give it to you as a negative vector. It'll say your vector is like negative 45.
Okay.
And then when you add 180 to it, you'll actually get up into the second quadrant. Yeah, it'll give it to you as either a positive vector, or it'll give you a positive angle or a negative angle. If it's a positive angle, it's in the first quadrant. If it's in a negative angle, it's in the fourth quadrant. Either way, if you add 180 to it, you'll get to the second or third quadrant. Good question. Okay, those are the two hardest parts about vectors because magnitude is incredibly easy. How do I find the magnitude? Yeah, you do the Pythagorean theorem. So the magnitude is just the square root of 50 squared plus 130 squared. Again, I make them positive because you're squaring them anyways. So why save yourself some heartache? What is it?
39.28.
139.28. So 139.3. And we don't know what type of vector it is. Okay. So here are the two formulas to go backwards. The angle is always going to be the inverse tangent of y over x. Make a note. If you're not using north, south, east, west, you have to do this. If your vector is in the second or third quad, add 180. If not, north, south, east, west notation. And then the magnitude is always just the Pythagorean theorem on the coordinates. Okay, so really there's four formulas. You've got the x notation, you got the y notation, you've got the angle, and you've got the magnitude. Okay, questions on? Okay, I want to do two examples. Go ahead.
Quick question. I'm just kind of confused about how why you said that angle was a 39 degrees when it's
Wait, I didn't say 139 degrees. 139 is the distance of the vector. It's the magnitude. The angle is 249 degrees. The magnitude is 139. No, good question. The issue is because I didn't have units, I don't know if it's meters, feet, meters per second. I didn't put any units. Okay, let's do a couple examples. Now you guys can go out in the real world and do some real trick. You start hiking east for 2 miles. You turn southwest and you walk 1.5 miles. Finally, southeast. Finally, you turn in a direction that is 30 degrees south of west and you walk for another 1 mile. From where you started, what is your total displacement and direction? So my first step is I'm just going to draw all 3 vectors. I'm going to draw them from the origin. It's easier to change them into XY notation if they're all drawn at the origin. So east 2 miles. And then southeast means 45 degrees. If it says southeast, it's due southeast 45 degrees. So southeast, 1.5. And then find 30 degrees south of west. If you don't mind, I like to do all my vectors from 0 degrees, even on the north, south, east, west plane, because not only does it give me the answer, it gives me the correct sign, and I don't have to fix it myself. Yeah?
On the right, between the 2 and the 1.5, that's the angle that's 45.
Yeah, that's the angle that's 45. Okay, now the first vector is incredibly easy to change into XY notation. It's a right angle vector. It's 2, 0, right? Okay, so 2, 0. How can I find the coordinates of the second one? What's the angle from 0 degrees? 45, but it's down. Negative 45. So if I do 1.5 times the cosine of negative 45 and 1.5 times the sine of negative 45, not only will I get the right answer, I'll get the right sign. If you just want to do 45 degrees, then you have to just fix it yourself. Okay, the second one, what's the angle 30 degrees if it was from 0? It's 180 past, what? It is 210. So this one would be 1 cosine of 210 and 1 sine of 210. The second one, if you wanted to do a positive angle, it would be 315, right? Because it would be 45 minus 360 would be 315. That'll also work. Okay, take a second. Find all of those angles in component form. I would round to 2 decimal points when you did this. First one I did, give me the second and the third. Anyone have the second one?
I got negative 0.87 and negative
0.87 and negative point. Actually, they should be the same. They should be the same. Double check.
Wait. Negative I made a 0.87 and negative 0.5 is the third one.
Oh, okay.
I got
Yeah.
I
I got
1.06
and negative 1.06.
Okay, so 1.06 and negative 1.06?
Yeah.
That makes sense because it's positive and then negative. Okay, and what was the last one, David?
Negative 0.87, negative 0.5.
And negative 0.85?
No, just 0.5.
Oh, negative 0.5. Oh, that's right. It's a 30, 60, 90. Negative 0.5. Okay, now add them together. Go ahead, Devin.
I got 2.19 and negative 1.56.
Negative 1.56. At least one confirmation, just so we're not off on a wild goose chase here.
The first
First one's right?
Yeah.
Cool.
Yeah.
Okay. Now, at this point, I would draw the resulting vector. You don't have to do it in a great fashion, but this will help me with figuring out if it gives me the right angle. So what I'm going to do is it's going to go to the right and it's going to go down. So this is going to be 2.19 and negative 1.56. You don't have to do it in any perfect fashion at all. Ooh. No. Wait. There it goes. Okay, it's back. Okay, now find the magnitude and the direction for me. The magnitude is just going to be the Pythagorean theorem on 2.19 squared and 1.56 squared. And the angle is going to be the inverse tangent of negative 1.56 over 2.19. The sign is not as important because it's north, south, east, west. I can figure out that it is south of east. Okay, what's the distance? 2.69?
Yep.
Okay, so 2.69, I'm going to round, my final answer I know I'm going to round to the nearest tenth, so 2.7 miles. That's how far I am from my starting point as the crow flies. And what's my angle?
Negative 35.40.
Okay, now notice it told me it was negative, so in other words, it's telling me that it's south. So I'll change it to positive and then I'll put the south part in my answer. So this is going to be 35 point, what was it again?
35.
35.5 degrees, and I can see that it is south of east. That's why I drew this picture, was to help me. It will always find the angle to the horizontal, and because it's in the first or the fourth quadrant, I don't have to do, I got it, it's fine. These ones I don't have to add 180 anyways, because it's north, south, east, west. Make sense? Okay, the next one I think is even easier than the first one. This one is dealing with a canoe. You are traveling by a canoe west across a river. In still water, you would be going 4 miles per hour. So you are going west 4 miles per hour. But you have a nasty little current that is moving at a rate of 1 mile per hour in a direction that is 50 degrees north of east.
That's a weird current.
We want to find out how fast is the boat moving because of the current, and in which direction is our boat moving. We're trying to go west, but we're not. We're drifting. Okay, so the first vector is easy. Negative 4, 0. Second one, we need a little trig. It is 1 times the cosine of 50 and 1 times the sine of 50.
0.6.
Why do you need to have it multiplied by the 1? Isn't it just the same?
Yep. What was it?
0.64 and then 0.77.
Is that what you got, David?
Yeah.
Okay. Was it negative 0.77?
I got regular 0.77.
Oh, that meant, yeah, 0.77. Add them together, negative 3.36 and positive 0.77. You can draw the resulting vector on the original graph. I'd like to draw it off to the side just so I can think about what it would look like. So it would be left and then up a little bit. Okay, I need a magnitude and I need a direction. So this will be the Pythagorean theorem on 3.36 squared and 0.77 squared. And this will be the inverse tangent of 0.77 over negative 3.36. Go ahead, Owen.
The magnitude is 3.4.
Okay, is the river hurting us or helping us?
Hurting us.
It's hurting us. We would go 4 miles an hour if there was no current, and we're only doing 3.4 miles per hour. So the current is definitely not helping us. And what angle are we off course? Go ahead, Christine. 12.9 degrees, and that's going to be the angle to the horizontal. So it's going to be north of west. So we are traveling currently at 3.4 miles per hour at 12.9 degrees north of west. Cool. Now, if this was one where I was doing from 0 degrees, it would be one where I'd have to add the 180. I don't have to, since I'm figuring out on the coordinate on the north, south, east, west exactly where I'm going. Okay. Questions on that one? Okay, get out your vector packet. I want to show you what you're doing for the second page. It's not nearly as hard as what it looks.
It looks hard.
Oh my gosh, it looks terrible. We're all gonna die.
They should be in the back where our advanced geometry stuff is, below the bin. Okay. What I want to do is I want you to add the vectors together. I want you to draw the resulting vector. You can draw it anywhere you have space. Most of the time I draw it somewhere in the picture, what I'm doing. And I want you to give me the magnitude of the resulting vector and the angle from 0 degrees. This is not a north, south, east, west one. This is from 0 degrees. Now, if vectors go from tip to toe, then it's very, very easy to add the vectors. When they are from tip to toe, how do you add them together? Well, we could calculate. Okay, let's do the first one. Let's calculate. Remember, you always name vectors as if their initial point is the origin. So what's the first vector? 4, 0. The second vector, remember, you always name as if the initial point is the origin. The second one is 0, 3. You add them together, you get 4, 3. So my resulting vector should go over 4 and up 3. I can draw it anywhere I want, but watch what happens if I draw it from the first vector over 4 up 3. Notice it goes to the top of the last vector. So that's my resulting vector. Now, when I name this vector, I pretend that its initial point is the origin. So I want to know what is that angle from 0 degrees, and I also want to know what's the magnitude of it. The magnitude's easy because it's a special right triangle. It's a 3, 4, 5 right triangle. Now to find the angle, you just do the inverse tangent of 3 over 4.
36.9.
Is this one that I have to add 90 degrees or 180 degrees to? No, I don't have to add 180 degrees to this one because it is a first quadrant vector. So it is 36.9 degrees. That's it. I'm done with that one. Now, someone said this only worked because it was a right angle, but do the second one. The second one is over 1, 2, 3 and up 1. So it is 3, 1. And the second one is over 1, up 3. And so my resulting vector is 4, 4. If I start at the very first vector and I go over 4 and up 4, I end up right at the top of the last vector. Yeah. That is true for any vectors in which you draw them so that the start of the next vector is where the first vector ends and you keep on going. I call it tip to toe. The next one starts where the last one ends. As long as you do that, you can always find the resulting vector by going from the very first one to the very last one. So that works for 1, 2, 3. Oh, 4 is where it stops not working. But you can play around and get it to work. Okay, now, so for this one, notice I drew the origin. This is the xy. So you have to do the Pythagorean theorem on 4 and 4, or it's a 45, 45, 90 triangle. If the legs are 4 and 4, the hypotenuse is going to be 4 root 2.
5.6.
What is it?
It's 5.6.
Yeah, I'm okay if you round it. 5.6. And the angle is going to be the inverse tangent of 4 over 4. Yeah, inverse tangent of 1. What is it? 45 degrees. Oh, that makes sense. Yeah.
How do you know that it was just 45?
Because if I go, if I go over and up, it's 4 and 4, and it's a right triangle and it's isosceles. Any isosceles right triangle is always going to be 45,
I
45
see what
degrees.
you're doing. But that means the whole angle is 45, not the small angle.
Okay, so if you're one who says, that's really cool that I can just do that little addition thing, if you do the next one, you can actually do it. You just have to move one of the vectors. Now, it doesn't matter what vector you move. So for number 4, what I can do is I can pick up this vector and move it so it ends and starts right there. And my resulting vector will now be from here to there. So instead of changing them each to component form and adding them together, if you want, you can pick up the vectors and move them, and then you can find the resulting vector. Either way works. Now, I just want to make sure, yeah.
I'll ask you.
Are you sure?
Yeah.
Okay. Yeah, go ahead, Owen.
For 2, why is it just that the angle, isn't that angle the whole thing?
It's from 0 degrees. So what you do is you pretend that the initial point is the origin, and then you see how I drew my axes right there? So I'm actually finding the angle from that horizontal line.
So you can just put that little.
Yeah, I always take my initial point and I draw little axes, and then I'm always finding the angle from there. It's not the angle up inside that triangle. Good questions. Any others? Yeah.
So for like, what's the end? Do you still have to do negative for the line?
Well, for number 3?
Yeah. No, 4.
Oh, for number 4, do you like the pickup way? Does that?
Yeah, it makes sense, but you still have a vector.
Yeah, the vector's blue, and it goes over 1, 2, 3, 4, 5, right? So it'll be -5, but it goes up 1. So my resulting vector would be that. And if you take each of the other vectors and change them into component notation, this would be 0, 3, and the other one would be 1, 2, 5, -2.
That's
Oh, -5, -2. If you add them together, you notice that you still end up getting. Either way works. Some people like to. Now, just to make sure you guys got this, there is one set of these vectors when you add them is 0. Can anyone find it? There is one set of these that when you add them, if you know them, wait, take a look, let everyone get a chance to see which one you think it is. But there's one set of these that you actually get 0 when you add them. Just take a look and see if you can find which one it is. We'll take guesses. Okay, who wants to make a guess? Go ahead, Owen.
7.
Okay, we had a guess for 7. Anybody else?
Oh, it's 12. It's 12.
Yeah.
Okay, we had a guess for 12. Anybody else?
12.
Go ahead, David. Which one?
It's actually 7.
9. Anybody else?
12.
Okay, let me go through and we'll figure out. Now, the number 7, if I pick up one of the vectors, so I'll pick up this vector and put it at the end, isn't it going to go from here to there? Not 0. So it's not 7. If I do 9, this one is actually set up from tip to toe. So this one, the resulting vector is from here to here, not 0. Number 12. Oh, you think it's 11? Okay, number 11. I would have to do a couple things. Suppose I pick up this vector and move it here, and then I pick up this vector and move it here. Nope.
It's 12.
It's actually this vector right here. 12. If I pick up this vector, and you can do this in any order. There's no reason why I picked this vector to move first. If I pick up this vector and move it, it goes here. And if I pick up the last vector and move it, it goes here. And guess what? I get right back to where I started from. So it would go up, over, down. That one is it. It is number 12. It is actually the 0 vector.
Wait, so it's 0, 0.
0, 0, and the angle would be non-existent. There's no angle from. So
Look at this.
if you had an object and you were pulling it in equal directions in these directions at the same force, the net force on the object would be 0. So if that object was being pulled in those directions, the net force on the object would be 0. Okay. Yeah, this is your homework over break over the mini break, is to finish the packet. The last one I think are the easiest. All you have to do is change them to XY notation, add them, change them back. The last thing, let's see, there was something else. Anyone not going to be here over break? I can give you your packet for next week early. Let me stop my recording.